So we've done a lot of work with simplifying rational expressions. Let's see what happens when we set some rational expressions equal to each other and we have to solve. Okay, so something to just keep in mind here is these can get a little bit complicated. We're looking at a couple simple examples here. In the next video, I'll go over a question from the homework that gets pretty intense. Um, but for now, we'll start with a couple simple examples. So a few things to keep in mind here. Um, factoring is going to be a big help in both simplifying before we solve, while we solve, and after we solve. Okay. A lot of times we're going to look to cross multiply. Okay. Um, that's something we've been doing since middle school. And, sometimes you might have multiple solutions because we'll end up with some quadratics. And we always want to check for extraneous solutions. Those are solutions that don't actually work. They result in division by 0. So in some number over 0, okay, which is a big no-no. So let's look at this first one. So I have 5 over x plus 2 is equal to 4 over x minus 1. So the first thing that I notice is that I don't have to do any factoring because these are already very simple. So I'm going to go ahead and I'm going to cross multiply. Now remember, when you're cross multiplying, essentially what you're doing, we'll just draw the arrows to kind of represent the x plus 2 going up on the right, the x minus 1 going up on the left. But really what you're doing is you're multiplying by these denominators on both sides, okay? And they're canceling out on their respective sides. So at the end of the day, what we're left with is x minus 1 up on the left and x plus 2 up on the right. Okay, that's why cross multiplication works. So we'll go ahead from here. It's just a really easy algebra 1 problem, right? We distribute, we solve for x. So we'll run through this really quick. This shouldn't be too bad for us. Distribute 5x minus 5, 4x, plus 8. Solve for x. Let's get the x's over to the left side. I like to subtract the smaller x. So those will cancel. Let's see, we have x minus 5 equals 8. Add our 5 to both sides. And we have x equals 13. And that's our solution. Okay, I know it's not extraneous because if I plug 13 into the denominator on either side, I'm not going to get 0. Okay, looking at one that is a little bit more work. Uh, Fortunately, nothing to factor yet. So we're going to cross multiply once again. I bring the x up on the left, bring the 3 up on the right. We'll go ahead and distribute this x here. Distribute the 3 on the right. So I have x squared plus 5x and 3x plus, let's see, 3 times 16 should be 48. Okay, so from here, here's what I see. I see I have an x squared. Okay, that means I'm going to have a quadratic to deal with. Okay, when we get anything in a quadratic form, this ax squared plus bx plus c, I want to move everything to the left so that I can have it set equal to 0, right? So that from there, I can factor if possible, and I can set the factors equal to 0 and solve that way. So let's move this stuff over. So I'm going to do this in one step. I'm going to subtract 3x from both sides. And I'm going to subtract 48 from both sides. Okay, so I get, let's see, x squared, nothing changed there. 5x minus 3x plus 2x, and then minus 48. This is all equal to 0. Okay, we have everything on the left. We can solve our quadratic in whichever way is most convenient for us. Personally, I like to factor if I can. So something that multiplies to negative 48 and adds to positive 2, that's going to be 8 and negative 6. Okay, remember, with quadratics, we set each factor equal to 0 and solve. So one solution, I'll get x equals negative 8. If I plug negative 8 into my original equation, is that going to be a problem? No. It's not going to give me 0 on the denominator anywhere. Other solution should be x equals, let's see, positive 6. We add 6 to both sides. Also not extraneous. And that's it. That's our solution. This one had two solutions. Eventually we're going to graph these things. The graphs do get pretty funky. What this means is the graphs intersect in two places.